as one Harvard professor is raising the theory this may actually be a piece of alien technology.
Scientists track thousands of objects in space, but the discovery of 3 IATLAS has them completely baffled.
This is really exceptional. You have to be an interstellar object to be going that fast at that distance from the sun.
An advanced AI first flagged this interstellar visitor, and its initial scan revealed something unbelievable. It's not just another comet passing through our solar system. The object is following a path so precise, so mathematically perfect, that it defies the laws of chance. You won't believe the planets it's scheduled to visit in a perfect sequence. This isn't a random rock. Its trajectory suggests something far more deliberate, and the secrets it holds could change our place in the universe forever. Not a random visitor. It all kicked off on July 1st when the Atlas survey system in Chile, a set of powerful robotic telescopes, flagged a fast-moving object cutting across the night sky. Think of Atlas as our planet's automated bodyguard, constantly scanning for anything that might get a little too close for comfort. Usually it finds asteroids, but this was different. The AI flagged it as an intruder, a dim, silent visitor entering from the direction of Sagittarius, right near the dense, star-packed core of our galaxy. At first, the call was simple. Another distant comet, a cold wanderer from the far edges of our own solar system, maybe the Oort cloud. But that easy explanation didn't even last a day. You see, the more telescopes that locked onto this object, the more the numbers just didn't add up. Astronomers quickly realized it was moving way too fast to be a prisoner of our sun. Its speed was incredible, meaning it was on what's called a hyperbolic trajectory. Picture this. If you throw a ball up, gravity brings it back down. That's a closed orbit. But if you could throw it fast enough to escape Earth's gravity entirely, it would fly off into space forever. That's an open path. And that's exactly what 3 IATLAS was on. It was inbound from the crushing darkness of deep space, destined to swing past our sun and then vanish back into the void, never to return. But here's the kicker. Its speed wasn't the biggest shock. It was the precision of its path. Most interstellar objects we've seen, like the famous Oumuamua or Borisov, come screaming in on wild, irregular paths. They dive through our solar system at steep, odd angles like a billiard ball shot randomly across the table. But this one was different. Believe it or not, 3 IATLAS was approaching on a trajectory just 5 degrees off the ecliptic. The ecliptic is the flat cosmic highway where all the major planets, from Mercury to Neptune, do their laps around the sun. For a random interstellar visitor to arrive on this exact plane is mind-bogglingly rare. It's like throwing a paper airplane from a skyscraper in another city and having it glide perfectly through your mail slot. And as the orbital models got more and more refined, something even stranger became crystal clear. The object wasn't just cruising on our local highway, it was using the off-ramps. It was set to pass near Venus, then Mars, and then Jupiter in that exact order. This is a gravity assist sequence, a cosmic slingshot maneuver that our own space agencies like NASA use to send probes to the outer solar system. It's a move eerily similar to the ones we painstakingly design for our own spacecraft to save fuel and gain speed. Now, is that kind of alignment impossible for a natural object? No, but it's not what you'd ever expect to see from a random interstellar rock. It's funny when you think about it. We spend decades planning these paths, and here comes a comet that nails it on the first try. In fact, Avi Loeb, the straight-talking Harvard astrophysicist known for challenging the status quo, publicly estimated the chances of such a sequence happening by pure coincidence at roughly 1 in 20,000. That's a number that doesn't prove anything by itself, but it's a number that refuses to go away. Then came the size estimates. Based on its brightness and assuming it had a dark, rocky surface like most comets, 3I-ATLAS could be up to 12 miles wide. That's massive, big enough to dwarf the island of Manhattan. This would make it by far the largest interstellar object we have ever observed. And yet, during its entire initial approach, there were zero visible signs of typical comet behavior. No jets of gas, no clear outgassing, not even a faint tail. Just cold, unnerving silence from an object that should have been waking up as it got closer to the sun's warmth. This silence might still fall within the realm of coincidence, but for those paying close attention, something about 3I-ATLAS felt profoundly off. Its path was just too clean, too calculated, and if its perfect flight path was suspicious, what our telescope saw when it finally woke up was even stranger. An engineered shell. For weeks, as 3I-ATLAS barreled closer, the silence from the 12-mile-wide object was deafening. Telescopes across the globe, and even the ones in orbit like Hubble, were locked onto it, trying to answer a question older than science itself. What exactly are we looking at? The object was a ghost. No obvious jets, no tail, no visual cue that it was shedding material as a normal comet would. Just a cold, massive core gliding through space with an unsettling stillness. But as it moved closer to the sun, inside the orbit of Mars, that finally changed. The ghost started to wake up. Slowly, a coma formed. That's the fuzzy, glowing envelope of gas and dust that surrounds a comet's nucleus. But its behavior wasn't typical at all. In most comets, the sun's radiation acts like a powerful wind, pushing gas and dust particles straight away from the sun, forming tails that can stretch for millions of miles. But something was wrong with the tail of 3I-ATLAS. Part of its dust stream seemed to bend toward the sun, as if heavier grains were actively resisting the push of solar radiation. This isn't supposed to happen. It suggested something unusual in its composition, something dense, maybe even metallic, or at the very least made of grains much larger and heavier than standard comet dust. Then came the really deep analysis. High-resolution instruments aboard the James Webb Space Telescope and Earth-based giants like the Gemini South Observatory in Chile started collecting its light and breaking it down, a process called spectroscopy. It's like a chemical fingerprint analysis for space objects, and what they found was both familiar and deeply unsettling. They found water ice, carbon-rich dust, silicates, and even complex organic molecules. On their own, these are common building blocks of comets. But here's the thing. These weren't fresh materials. The data suggested they were ancient, possibly 7 billion years old, older than our sun and our entire solar system. They were preserved in a pristine state, as if they had been sealed away in a cosmic deep freeze for eons. Get this. Some of these compounds showed minimal radiation damage and almost no signs of ever being heated up. The spectral features suggested they had never been close to a star until right now. It was like finding a perfectly preserved fossil from the dawn of the galaxy. Even stranger was the mismatch between its brightness and its size. The coma was unusually luminous, glowing brighter than it should have, yet the estimated nucleus remained smaller than expected for that level of activity. This led some scientists to propose a wild alternative. Maybe the surface isn't just reflective. Maybe it's unusually efficient at scattering light, perhaps because it has a smooth, polished texture, or even an engineered shell. At this point, every new piece of data just deepened the mystery. The more we learned, the more contradictions appeared. It was like trying to identify an animal that has the fur of a bear, the wings of an eagle, and the fins of a shark. It just didn't fit into any known category. And perhaps the most disconcerting piece of the puzzle is its origin. By tracing its impossible path backward, astronomers pinpointed its point of origin to the direction of the thick disk of the Milky Way, a region dense with ancient stars and primordial debris. It's far from the younger, brighter stellar nurseries where new planets are usually born. This suggests 3 IATLAS may have been traveling for billions of years before arriving on our doorstep. It could be a fossil, a shard of galactic memory, unaltered since the beginning of time. Or it could be something else entirely. A fragment of design, a long-dispatched probe, a silent watcher awakened by the light of a new star. And just as we were getting our best look, it prepared to perform the ultimate vanishing act. A message in the silence. So let's step back for a second and look at what we have. An object from another star, 12 miles wide on a 1 in 20,000 trajectory that mimics our own space probes. It's made of materials older than our sun but is acting like no comet we've ever seen. And just when you think it couldn't get any weirder, you have to consider the timing of it all. As 3 IATLAS races toward its closest approach to the Sun, it's scheduled to do something that, for astronomers, is the worst-case scenario. It will pass directly behind the solar disk from our perspective, entering a window of observational blackout. This blackout will happen at the exact moment when its activity, the outgassing, the coma, the tail, is expected to peak. It's the moment we would learn the most about it. Ground-based telescopes won't be able to track it through the sun's blinding glare. The Hubble Space Telescope will be blinded. Even the mighty James Webb Space Telescope will have to maneuver carefully to avoid damaging its sensitive instruments. To some, that's just a classic case of bad luck, a cosmic inconvenience. But to others, it borders on tactical, as if the object were designed to vanish at the very moment of greatest scrutiny. It's easy to dismiss that as science fiction, but the physics behind it is surprisingly simple. A tiny adjustment to its course, a small push of just a few centimeters per second, would be enough to subtly shift its trajectory over the billions of years it has been traveling. If 3 IATLAS were equipped with any form of propulsion, even a passive or ancient system like a solar sail, that level of course correction would be more than plausible. Of course, there's no direct evidence of an engine, but the series of anomalies forces you to wonder, why does every strange detail seem to point in the same direction? Soon, 3 IATLAS will be gone. It will vanish behind the sun, hidden in its glare, unreachable by even our most powerful eyes. When it emerges again weeks later, it will be quieter, colder, and fainter, already on its way out. A silent stranger slipping back into the void from which it came. We'll be left with piles of data, charts, and images, all of it remarkable, and yet none of it is likely to be conclusive. The thing is, we may never know for sure whether this was a comet like no other or something more deliberate, something designed to pass close, but not too close, to show just enough to make us look, but never reveal everything. Maybe it's just a string of coincidences, a natural relic from a distant system following an improbable path through ours. But what if it isn't? What if the trajectory, the ancient chemistry, the strategic silence, and the final disappearing act all point to something artificial? Then 3 IATLAS might be the first real message we've ever received. A message from a civilization that may be long gone, or one that still watches quietly from the darkness. A probe that doesn't communicate, doesn't land and doesn't wait. It just moves, observes, and then disappears. And maybe that's the most unsettling part of all. Not the possibility that we were visited, but the chilling idea that we weren't the destination, that we were just a stop along the way, a waypoint in the dark. Was 3IA TLAS a natural wonder or a piece of technology billions of years old? Let us know your theory in the comments. Like and subscribe for more journeys into the cosmic unknown.